Hi guys, in this video, I will be introducing to you to the second technique in proving the trigonometric identities. And this second technique is we will be factoring and using the Pythagorean identities. Now let's recall the Pythagorean identities. We have sine squared x plus cos squared x equals 1. Another Pythagorean identity, we have tan squared x plus 1 equals sec squared x. And the third one is 1 plus cot squared x equals cosecant squared x. So we will be using these Pythagorean identities in order to prove a trigonometric identity. Now, we have here an example. Let's try to verify the identity cosecant squared x minus cos squared x times cosecant squared x equals 1. So solution, first we will factor the expression. So we will factor this expression cosecant squared x minus cos squared x times cosecant squared x. We will factor them. So this will become cosecant squared x times the quantity 1 minus cos squared x. So this is the result when we will be factoring this expression. So cosecant squared x times the quantity of 1 minus cos squared x. So that is equal to 1. Now, cosecant squared x can be rewritten as 1 over sin squared x. So remember, this is the reciprocal identity for cosecant squared x. So just recall that while 1 minus cosecant squared x can be also rewritten as sin squared x, remember the Pythagorean identity. Sin squared x plus cos squared x equals 1. So we could get the sin squared x, or we could say that sin squared x is simply equal to 1 minus cos squared x. That is why 1 minus cos squared x can be rewritten as sin squared x. So from here, we could cancel sin squared x and this one sin squared x. So that simply means that this expression would be equal to 1. So 1 equals 1. So we have already verified this expression or this identity. Cosecant squared x minus cos squared x, cosecant squared x equals 1. So that's it. That is just how to use the factoring and the Pythagorean identity to prove a trigonometric identity. Now let's take the second example for you to understand this concept better. So for example, we will be verifying the identity sine to the power of 4 x minus cos to the power of 4x equals sin squared x minus cos squared x. Remember, this is not the Pythagorean identity. It should be addition. So definitely this is not equal to 1. Okay? I hope you noticed that. Now, solution. So sin to the power of 4x minus cos to the power of 4x equals sin squared x minus cos squared x. So we can factor this trigonometric expression. So we can factor this one, so that becomes sin squared x plus cos squared x times sin squared x minus cos squared x. So remember the special products. So this is the sum. This could be rewritten as the sum, the difference of square. So this becomes, or this can be rewritten as sin squared x plus cos squared x times sin squared x minus cos squared x. So this is equal to sin squared x minus cos squared x. Remember that this sin squared x plus cos squared x can be rewritten. So this is one of the Pythagorean identities. So that is just simply equal to 1. So we can write this as 1 because sin squared x plus cos squared x, that is equal to 1 as the Pythagorean identity states. And we just copy this one, this expression. So 1 times sin squared x minus cos squared x, that is simply sin squared x minus cos squared x. So that is equal to sin squared x minus cos squared x. So we have already verified the identity. So we have come up to the same expression, sin squared x minus cos x squared, verifying the given trigonometric identity. So that's just it. That is just how to prove trigonometric identities by factoring and by using the Pythagorean identities. That's all for now. Thank you, more power, and I hope that this video helps.